Packet radio. Packet radio is a digital radio communications method used to send packets of data. Packet radio uses packet switching to transmit datagrams. This is very similar to how packets of data are transferred between nodes on the Internet. Packet radio can be used to transmit data long distances. Packet radio is frequently used by amateur radio operators. The AX. Every AX25 packet includes the sender's amateur radio callsign, which satisfies the US FCC requirements for amateur radio station identification. AX25 allows other stations to automatically repeat packets to extend the range of transmissions. It is possible for any packet station to act as a digipeater, linking distant stations with each other through ad hoc networks. This makes packet radio especially useful for emergency communications. Packet radio can be used in mobile communications. Some mobile packet radio stations transmit their location periodically using the automatic packet reporting system APRS. If the APRS packet is received by any gate station, position reports and other messages can be routed to an Internet server and made accessible on a public web page. This allows amateur radio operators to track the locations of vehicles, hikers, high-altitude balloons, etc., along with telemetry and other messages around the world. Some packet radio implementations also use dedicated point-to-point links such as TARPN. In cases such as this, new protocols have emerged, such as improved Layer 2 protocol IL2P supporting forward error correction for noisy and weak signal links. Timeline. Earlier digital radio communications modes were telegraphy using Morse code, teleprinter using baud code, and facsimile. Aloha NPRNet. Amateur packet radio and the AMPRNet. Amateur radio operators began experimenting with packet radio in 1978 when, after obtaining authorization from the Canadian government, Robert Rouleau, V. Etwo Pi Bram Frank, V. Etwo BFH, Norm Pearl, V. Etwo BQS, and Jacques Orsali, V. Etwo EHB of the Montreal Amateur Radio Club Montreal, Quebec began. In 1980, Doug Lockhart via 7APU and the Vancouver Area Digital Communications Group VADC in Vancouver, British Columbia began producing standardized equipment terminal node controllers in quantity for use in amateur packet radio networks. In 2003, Rouleau was inducted into CQ Amateur Radio Magazine's Hall of Fame for his work on the Montreal Protocol in 1978. Not long after this activity began in Canada, amateurs in the US became interested in packet radio. In 1980, the United States Federal Communications Commission (FCC) granted authorization for United States amateurs to transmit ASCII codes via amateur radio. Repeaters may be designed for amateur packet radio. These are dubbed digipaters. The first known amateur packet radio activity in the U.S. occurred in San Francisco during December 1980, when a packet repeater was put into operation on 2 meters by Hank Magnuski K6M and the Pacific Packet Radio Society PPRS. In keeping with the dominance of DARPA and ARPANET at the time, the nascent amateur packet radio network was dubbed the AMPRNet in DARPA style. Magnuski obtained IP address allocations in the 44.0.0.0/8 network for amateur radio use worldwide. Many groups of amateur radio operators interested in packet radio soon formed throughout the country, including the Pacific Packet Radio Society PPRS in California, the Tucson Amateur Packet Radio Corporation TAPR in Arizona, and the Amateur Radio Research and Development Corporation AMRAD in Washington, D.C. By 1983, packet radio started becoming more and more popular across North America, and by 1984 the first packet-based bulletin board systems began to appear. Packet radio proved its value for emergency operations following the crash of an Aeromexico airliner in a neighborhood in Cerritos, California in August 1986. Volunteers linked several key sites to pass text traffic via packet radio, which kept voice frequencies clear. For an objective description of early developments in amateur packet radio, refer to the article Packet Radio in the Amateur Service. Commercial systems. Many commercial operations, particularly those that make use of vehicle dispatch, i.e. taxis, tow trucks, police, were quick to note the value of packet radio systems to provide simple mobile data systems. This led to the rapid development of a number of commercial packet radio systems: NDI 1979, DCS 1984, DRN 1986, Mobitex 1986, RDS 1990. CDPD allowed packet data to be carried over AMP's analog cellular telephone networks. GPRS is the packet data facility provided by the GSM cellular telephone network. Technical details. Voice, not data. One of the first challenges faced by amateurs implementing packet radio is that almost all amateur radio equipment and most surplus commercial/military equipment has historically been designed to transmit voice, not data. Like any other digital communications system that uses analog media, since the radio equipment to be used with the modem was intended for voice, early amateur packet systems used ASC modems that followed telephone standards, notably the Bell 202 standard. While this approach worked, it was not optimal because it used a 25K HCFM channel to transmit at 1200 baud. When using a direct FSK modulation like G3 RUH packet radio modem, a 9600 baud transmission is easily made in the same channel. In addition, the baseband characteristics of the audio channel provided by voice radios are often quite different from those of telephone audio channels. This led to the need in some cases to enable or disable pre-emphasis or de-emphasis circuits in the radios and /or modems. Synchronous framing. Another problem faced by early packeteers was the issue of asynchronous versus synchronous data transfer. At the time, most personal computers had asynchronous or SMINUS 232 serial ports for data communications between the computer and devices such as modems. The SMINUS 232 standard specifies an asynchronous start-stop mode of data transmission where data is sent in groups characters of 7 or 8 bits. Unfortunately, the simple ASC modems typically used provide no timing signal to indicate the start of a packet frame. That led to the need for a mechanism to enable the receiver to know when to start assembling each packet frame. The method used is called asynchronous framing. The receiver looks for the frame boundary octet, then begins decoding the packet data that follows it. Another frame boundary octet marks the end of the packet frame. Sharing the channel. A number of data conversations are possible on a single radio channel over a finite period. Station configuration. A basic packet radio station consists of a computer or dumb terminal, a modem, and a transceiver with an antenna. Traditionally, the computer and modem are combined in one unit, the terminal node controller TNC, with a dumb terminal or terminal emulator used to input and display data. Increasingly, personal computers are taking over the functions of the TNC, with the modem either a standalone unit or implemented entirely in software. Alternatively, multiple manufacturers including Kenwood and Alinco now market handheld or mobile radios with built-in TNC, allowing connection directly to the serial port of a computer or terminal with no other equipment required. The computer is responsible for managing network connections, formatting data as AX, 25 packets, and controlling the radio channel. Frequently, it provides other functionality as well, such as a simple bulletin board system to accept messages while the operator is away. Following the OSI model, packet radio networks can be described in terms of the physical, data link, and network layer protocols on which they rely. Physical layer modem and radio channel. Example of packet radio transmission in 1200 bits per second modems used for packet radio variant throughput and modulation technique, and are normally selected to match the capabilities of the radio equipment in use. Most commonly used method is one using audio frequency shift keying ASK within the radio equipment's existing speech bandwidth. The first amateur packet radio stations were constructed using surplus Bell 202 1200-bit/S modems, and despite its low data rate, Bell 202 modulation has remained the standard for VHF operation in most areas. More recently, 9600-bit/S has become a popular, although more technically demanding, alternative. At HF frequencies, Bell 103 modulation is used at a rate of 300-bit/S. Due to historical reasons, all commonly used modulations are based on an idea of minimal modification to the radio itself, usually just connecting the computer's audio output directly to the transmitter's microphone input and receiver's audio output directly to the computer's microphone input. Upon adding a turn the transmitter on output signal PTT for transmitter control, one has made a radio modem. Due to this simplicity, and just having suitable microchips at hand, the Bell 202 modulation became standard way to send the packet radio data over the radio as two distinct tones. The tones are 1200 Hz for mark and 2200 Hz for space 1000 Hz shift. In the case of Bell 103 modulation, a 200 Hz shift is used. The data is differentially encoded with an NRZI pattern, where a data 0 bit is encoded by a change in tones and a data 1 bit is encoded by no change in tones. Ways to achieve higher speeds than 1200 bits/S include using telephone modem chips via the microphone and audio out connectors. This has been proven to work at speeds up to 4800 bits/S using fax V27 modems in half-duplex mode. These modems use phase shift keying, which works fine when there is no amplitude shift keying, but at faster speeds such as 9600 bit/S signal levels become critical, and they are extremely sensitive to group delay in the radio. These systems were pioneered by Simon Taylor Gone in TX and Jerry Sandys JDXC in the 1980s. Other systems which involved small modification of the radio were developed by James Miller G3 RUH and operated at 9600 bit/S. 1200 bit/S ASK node controllers on 2 meters 144-148 MHz are the most commonly found packet radio. For 1200/2400 bit/S UHF/VHF packet radio, amateurs use commonly available narrowband FM voice radios. For HF packet, 300 bit/S data is used over single sideband SSB modulation. For high-speed packet 9600 bit/S upwards, special radios or modified FM radios must be used. Custom modems have been developed which allow throughput rates of 19.2 kbit/s, 56 kbit/s, and even 1.2 mbit/s over amateur radio links on FCC permitted frequencies of 440 MHz and above. However, special radio equipment is needed to carry data at these speeds. The interface between the modem and the radio is at the intermediate frequency part of the radio as opposed to the audio section used for 1200 bit/S operation. The adoption of these high-speed links has been limited. In many commercial data radio applications, audio baseband modulation is not used. Data is transmitted by altering the transmitter output frequency between two distinct frequencies in the case of FSK modulation. Other alternates exist. High-speed multimedia radio. The 2.4 GHz Wi-Fi band partially overlaps an amateur radio band, so commercial Wi-Fi hardware can be adapted and used by licensed amateur radio operators at higher power levels, although restrictions on amateur radio limit the appeal of using packet radio to connect to the Internet. US FCC regulations do not allow amateur radio communications to be encrypted or private, in addition to other content restrictions. Datalink Layer AX25. Packet radio networks rely on the AX25 data link layer protocol, derived from the X AX25 protocol suite and intended specifically for amateur radio use. Despite its name, AX25 defines both the physical and data link layers of the OSI model. It also defines a network layer protocol, though this is seldom used. Network layer. Packet radio has most often been used for direct keyboard-to-keyboard connections between stations, either between two live operators or between an operator and a bulletin board system. No network services above the data link layer are required for these applications. To provide automated routing of data between stations important for the delivery of electronic mail, several network layer protocols have been developed for use with AX25. Most prominent among these network layer protocols are NET/ROM and the NET rows, FlexNet and TextNet. In principle, any network layer protocol may be used, including the ubiquitous Internet Protocol.